All right, so the next section is operational planning tools in TBES. So let's take a look at that. All right, so we'll start with bus stop balancing, APC Ridership Imports, Advanced Grade Tool Outputs to ArcGIS Online, BRT Adjustments, and Load Factors. All right, so one of the new tools that we have in this release of TBEST is this bus stop balancing add-in that can be used to evaluate and rank stops for removal slash balancing. And it can be found under the TBEST tools menu. And as all add-ins are, and automatically identifies candidates for removal along each route, and then sets parameters and scoring variables for removal. So the target stop spacing is here. So you can modify this if you want to, but this is the kind of the limit that you want to go to for spacing and for removal. So you don't want to go remove stops that are greater than 1320 feet, basically. So the stop dwell time is another input because one of the outputs of this is the travel time savings if you remove the stop. And so the dwell time is part of that. You can also filter the stop balancing within a geography. So that takes a mobility area as an input. So if you select a route or multiple routes and you say, I want to only balance the stops that are within, let's say, the city of Gainesville. Outside of the city of Gainesville, it doesn't matter. Inside is where I want to balance at a certain density of stops. So it might be 1320, maybe it's less than that or more than that. So you can make that decision, but you would only filter those and give you the results for stops that meet that geographic criteria. And then also you have your scoring variables. So and this is basically the weighting of the variables. So 150, 30. Rider activity, that's something if you have the actual observed ridership, this can be set to 30 as well, but this is set to 0, I guess, because there's no ridership data in that particular scenario. Population 10, employment 10, minority 50, low income 10. And you can modify these to score your stops based on what you feel is the most important criteria. There are some exclusions with this where ridership ons and off are greater than a value. You can turn this off if you want to. You can turn off the school exclusion, transfer exclusion, and exclude stops with facilities. So, so these are exclusions where it won't seek to balance these particular stops. So that's kind of cool. And then the output for this is a listing and ranking of stops that meet based on their total score. So here's the total score with a max of 250. And the rank is here. So you can see this ascending rank. So the further you get up the list, the more likely that is to go away. So this example, we actually went in and removed his Route 22 stops before they were moved, and then after we removed them. So this is the ranked stop. So we removed everything up to this 53 ranked because this demarcation between green and red is where you get from 1320 to 1346. So this is the result stop spacing. So once you start removing stops, then it's automatically going to rescore all of the stops. So whenever you run this process, you remove a stop and then you re-rank. Remove a stop and re-rank, because once you remove the stop, then the stop distances change. So then you have to re-rank. And that's how you can get to this where you have a nice proportion of stops and how they're spaced along the route. So this was a pretty dense stop spacing. So you can see that it started down like 600 feet, something like that in terms of stop spacing. So really dense stops spacing. And then this is the weeding out of that to 1320. And the total travel time savings can be calculated from that as well. All right, so we're going to do a little bit of work with this bus stop balancing tool, so you can see some of this as well. All right, so operational planning for the query tools. So you can build the query tools, you can produce the output data sets, and you can export those out to lots of tools, including Excel, which you can build this type of observed boardings and a lighting chart that would displays the lightings and boardings from stop to stop to stop. You can also export out to ArcGIS online. So this is actually another link that we have to another web map. So here is another web map based on lightings and share minority. So it provides the arrivals in stop arrivals, and then the share of minority is the color coding scheme, right? So this is taking into account that stop level data set that we exported, where you had variables for share minority, and we have variables for the same data set we had the number of arrivals. So that's how we can do this kind of association within ArcGIS Online very easily. So the query tool output, because it contains one data set contains all these variables, then you can mix and match them in ArcGIS Online in the same data set very easily without joining and doing all that. So all the joining is done for you, and the output you can use directly in any environment. So we mentioned the load factors early on, and I just want to maybe reiterate that just a little bit to show that you can use this in your applications. And so, so this is the T-best interface for your passenger miles, your max load ratio, your average load ratio, and then your stop-to-stop load ratio as a chart, right? And all this can be exported out of T-best and into other environments, right? And so I think we showed early on where you could export this out, and JTA and their TDP had done something very similar to what T-best would export out. So, so that's another place where you can push this data out and into a TDP and use this data interactively as well. Okay, so the other operations planning is scripting. So, so we haven't talked too much about the scripting yet, but you can use T-best scripting API to create add-ins. So for any planning application using T-best data or data that you would bring in as references through the scripting. So you're not limited to T-best data at all. You can use the API to manipulate what's in T-best, but you can have ArcGIS API, you can have other API calls inside of your scripting to kind of merge a lot of your workflows into what might be, or not a lot of workflows, but maybe a single workflow that requires several data sources and to be able to process. So some examples of this are the bus stop balancing tool is an add-in. It's not a core T-best inside of the application itself. It is an add-in, and that was developed towards the city of Buffalo, actually, to produce some bus stop balancing. You also have tools that we've developed for APC stop ridership imports. So that's something we've done ourselves for our customers that are using T-best that want to get their APC data in. We've built add-ins to do that. And usually that's more or less client specific because all the APC data is different from every customer across the board. You know, none of the APC data is the same. So it usually takes a unique script of some sort to be able to process it. We also built a script to compare for bus stop signage, where you take two GTFS files and you compare them and you return the deltas in service by route and stop to say which routes now serve which stops. So You show the before and after, and then you can change your bus stop signage based on the GTFS change. So we built a script that was for Nashville. We're currently working on a transit orientation index or community accessibility tool for Valley Metro. And that one will take into account the TBES data, but we're also going to bring in data sets that are local to them for like shade. Obviously, is a big indicator of walkability in that area where people seek out the shade. Crime, other kind of walk access and impedances, et cetera, as it relates to transit. So we're building something for them for that. So there's lots of things that you can do with this tool and scripting tool that you wouldn't normally be able to do just with TBES out of the box. This gives you a lot of power to do that. And it's all in the Microsoft Visual Studio development environment. Now, if you're going to add maps to your TBES scripting, then you need to have, at least for this version of TBES, you're going to have a license from Esri to do that. So if you're going to have a developer license. So just keep that in mind if you want to start adding maps to your scripting as an interactive map, then you're going to need a developer license to do that. Okay, so let's take a look at a couple things before we start with our exercise. Number one is this the scripting itself. So if we go to the scripting here, we have bus stop balancing as a script, and we have sample application. So if you right click on these, you see that you can open this in Visual Studio. You can also create a TBES add-in here. So essentially, whenever we created the bus stop balancing add-in, which is located here under Tools, bus stop balancing, really all we did was say, create TBES add-in once we created the application, and then it posts it up to the Tools menu where it's accessible to you as an add-in. So it's basically the compiled version of this particular tool. So if I right click on this and open in Visual Studio, the bus stop balancing, I have Visual Studio installed, and it is the Microsoft Visual Studio Express 2013 for Windows Desktop. So this is a free version of Microsoft Visual Studio. You do not have to pay for it. All you have to do is install it and probably register with Microsoft. So that's what this is built in, and you can see that you have the source code here that can be run, and I can set a breakpoint at this location, and if I run the bus stop balancing from here, basically it's going to go out to your TBES API, to your ArcGIS API, all of those, and reference those in, and you're off and running with an interface that you can build in Visual Studio that references the TBES API. So you can see here it has a list of transit systems. So if I select Gatorville, that's my only transit system that I have. I'm going to select a June 2021. So when I do that, it's going to go out and load that scenario. But it's also going to stop at this breakpoint. I set this breakpoint for when it's looping through all the routes in a scenario, right? So when I referred to the TBES API earlier, it was referring to objects that make up the TBES API. And one of those objects is a scenario object, which has information about that scenario in it that you can access through the API, right? So you can see that the model name is TBES Land Use Model 2018. The scenario path is here. You have the site buffer size, the growth rates, the spatial reference, the stop ID list, the TBES system that it's related to, the wage rate. So all of those items that we entered in TBES and are all kind of accessible here through the API, right? And so what I'm looking for is this route group. So this is a list of routes. So there are 52 routes that are listed in this system. And so I'm looping through each one of them. And when I do, it sets this route group equal to a route, right? So it has a route color, the route description, the fact that it's a radial, probably has a name in here somewhere. Route name is equal to 1. All of this. So all of this data is available to you through the API. So when I say API, this is what I mean by that. That you can get this T-best objects and refer to them and then build your interface around them and your processing around them. So I'm going to unbreak that point and I'm going to let it run. And so it builds in that list of routes just from what we were looping through. It just added those to this list and we're able to select them and do the analysis on them. Okay, so what I want to do is I'm going to keep this open, but on your end, you're going to go to the Tools menu in T-best and go to Bus Stop Balancing. So you're going to execute it from the add-in. Unless you have Visual Studio, you're not going to be able to do that, what I just did. All right, so in our instructions over here, has bus stop balancing. So, all right, so you want the Gatorville June 2021 scenario, which is what I have selected here as well. So you want to make that selection. And when it'll load up all the routes. And we're going to select Route 1 as our analysis. And just kind of review what we're doing here. So here's our scoring point max values. So 150 for stop distance. That means that this one is weighted the highest. Connectivity is weighted 30, rider activity is weighted 30, and population, employment, minority, low income. Now you may want to weight these differently, and if you do, that's fine. It will, prioritize any one of these variables over the other if you change these scoring elements. And it still has these exclusions. So we could turn these off or on based on what we want to exclude or not exclude, or we can change this value to be something greater than 30, but we'll leave that for now. And we'll just hit run scoring when we're ready. And basically it immediately pops up our information and we can kind of scroll through. So here are our stops on Route 1 that are kind of candidates for removal. And you can see that it mixes the patterns. So some of them are Route 1 eastbound, some are on Route 1 westbound. So just be aware of that it looks at all of the stops on all of the patterns for removal. And so so here's route stop 45. It has the distance scoring of 150, which means it's greater than 1320. And the rider max is 30, which is, or the value is 30, which probably means it has 0 ridership. Population of 10, which means it probably doesn't have any population. It does have employment, which is 0. It's not adding to the score. Minority of 10, low income 10, and connectivity of 0. So this score is 210, and that is the highest score, which makes it the most likely candidate for removal. And so what this is doing is saying, if you remove this stop, the stop spacing on the route is going to be 915. If you remove the next stop, it will be 932 on down to where it gets to 1320, and then it turns red because our threshold was at 1320. We didn't want to remove anything over 1320. Our target was 1320, so these are the stops that are prioritized to get you to the 1320 removal. So we can export this to Excel, and bus stop balancing is fine. And what we want to know is, what is our total travel time savings if we remove Everything before this is our resulting stop spacing. So everything that's before the 1320, and we just kind of do a quick Excel sum here of 44. So basically 44 seconds is what you're saving in this, right? So if you remove those stops in travel time. And the way that it calculates this is based on the riders, right? So if you have 0 riders, on average, it will never stop at that stop because the bus driver will just see nobody's there and keep going. So basically, it uses the ridership to determine the resulting travel time savings based on the dwell time input that was right here, this dwell time, which you can change if you have a higher dwell time that you want to put in. So all of this is highly kind of modifiable in terms of the output for it with changing the scoring. And you can do multiple routes, and each one, if let's say we select route 2, 3, and 5, and you hit run scoring, it will give you a table, an independent window for each one, right? So each one has its own window and for stop removal, right? And scoring. And
Hey, Rodney, could you go back to, yes, could you go back to the bus stop balancing? So Daniel asks, in terms of scoring, so the 150 for the stop distance, would that be a stop that is 1,320 feet from a previous stop?
no, that's not. That is the points that are awarded. Um, basically, based on the stop distance from the preceding stop and the next stop, what its distance is for them on average between the two. And then if it's greater than 1320, then or less than, kind of as it gets closer and closer to the previous stops, then the score will go up, right? Because it's too closely spaced. If it's too closely spaced to stops around it, then the score will go up. And because this is the weighting for it, meaning the higher the closer it is to other stops, the closer that it gets to this 150 variable or the 150 total score, right? So this is a scoring mechanism for stop distance relative to the stop distance from any one stop to its neighboring stops before and after it. So that's what that's for. Hopefully that answers the question. But it is basically because that is our biggest weighting that we want to do is stop distance. Others are important as well. Ridership is very important. Connectivity is important. But really stop distance is what we're after here. Is that, hopefully, Daniel, that answers your question. And what I would say about this is the good thing about it is all of the code that does all of those calculations is in this script that is available to you. And if you install Visual Studio, you could run this too, and you can change it, right? So there's nothing stopping you from having Visual Studio on your machine, opening the bus stop balancing, going into these bus stop balancing class, where you have a class that is stop balance scoring variables, and looking at all of the procedures that happen inside of this to see how it calculates all of this that it does for the bus stop balancing. So what I would say is that, if you really want to dig into this and kind of even customize this to be what you want it to be, then you can certainly do that. And you can dig into all this code and look at how it works. What I would also say, if you do that, I'm just going to stop this. I'm going to close it. You want to copy it first. So you can copy these. Just copy it to bus stop balancing, my bus stop balancing, or whatever it is you want to copy it to. and then you'll have a copy of it. You can always come back to the original and start again, or have the original code once you start changing. So yeah, so it's and all of this is just local here. You're accessing it from TBEST, but the reality is that all of this data is really just in your TBEST directories. Here's your CTBEST under tools, scripting. I have bus stop balancing, and here's my Visual Studio files, right? So here's my solution file for Visual Studio. If I double click on it, it's the same exact thing as if I launch it from here, right? So you have all these files locally that you can use for your scripting. All right, so we were talking about bus stop balancing and scripting. So those are parts of it, and I think that's all we wanted to do for this. I think we were going to filter to mobility areas as well, but we can save that for another time. It's getting late in the day. So